Security here at Nora. I'm introducing our first speaker, Chris Dale. He's an IT enthusiast who had childhood dreams of becoming a hacker, a dream set in motion after his older brother hacked him. That sounds like an interesting story. Today, Chris uses his hacker skills to demonstrate risk through offensive services and incident response. In 2020, Chris founded his own company, River Security, which specializes in offensive services, attack surface management, and cyber consulting. His speech today is called Hardware Hacking and Methodology. Take it away.
Thank you very much. All right, cool. Yeah, a story for a later time, how my older brother hacked me. But it was a rat, a remote access Trojan. Beer, come talk to me over beers and we'll do war stories. Speaking of war stories, if you have a war story and you want to tell me a cool story, I have these tarot card thingies that I can give you as a reward. And also went out for beers last night, and for some reason I had a vision of a golden duck. Nobody seen a golden duck before? Apparently there's one here at the venue, but I'm not sure if you can find it. Anyways, so my name is Chris Dale. Yes, I'll be speaking on pen test methodology, hardware hacking a little bit as well. I love to do public speaking because there is a lot of, well, things we get right in this industry and things we get wrong in this industry. And today is going to be a little bit about both things. Basically, I do pen testing and I do incident response. And together with a whole lot of other companies. This industry is amazing. In Norway alone, we got 50 plus companies doing pen testing, right? And I'm not here to gatekeep anything, but with 50 plus companies, there's bound to be a lot of diversity around pen testing and methodologies about how to do testing. I'm out here compiled a really good list of companies that can all provide services around pen testing. So what is pen testing? Let's take a look at pen testing methodologies, shall we? Let's go out there and look to see if we can figure out, well, what the industry is telling us on how to do pen testing. So I Google, and I did this Google search just a few weeks ago. I Googled pen test methodology, and as you can see, there's lots of recent material about the latest pen testing methodologies, about the different steps involved in pen testing methodologies. For example, you can see that there's some initial scoping, there's some recon phases, etc. There is a lot about preparation, constructing attack plans. There's a lot of methodology about even just getting ready to do pen testing. And if you do pen testing yourselves, very often that phase is actually skipped. Because when we do pen testing, the customer tells us what the scope is. The customer does the initial planning and the initial reconnaissance. They say, we want you to pen test this and this and this. And I'm left with not having, well, full freedom to do what I need to do to prove risk. Anyways, so we got some methodologies out there and we can dig deeper into the methodologies. For example, we can see the top 5 penetration testing methodology and standards out there today is OWASP, the Open Web Application Security Project. It's actually wrong. Anybody know the actual acronym OWASP is for? The Open World Application Security Project. They just renamed recently because it's not just web applications. It's also for hardware testing. It's also for mobile application testing. It's a lot more than just web apps. But we got the pen testing execution standard listed as a methodology. We got the OSSTMM as a pen test methodologies. And these methodologies are all in use in the companies out here and there on the internet. We use these methodologies to do pen testing. For example, here is some Norwegian vendors. And I don't want to name and shame anybody, but they're pretty open about using the pen test execution standard as their pen testing methodology. And the pen testing execution standard lists out things like reconnaissance and so on. Here we have another one. They do pen testing according to the pen testing execution standard. So let's dig into the standard, shall we? Let's open it up and ask ourselves, WTF, what are these acronyms? What is this? What is it all about? Instead of just saying we're doing pen testing according to OSSTMM, let's dig into it. First, the pen testing execution standard. I did this screenshot today. This methodology is archaic. It is more than 10 years old. It was last updated 2014. If we go into the methodology, we will see like a wall of text for how to test for SQL injection, for example. How do we test for process scripting? Well, turns out they need contributions. And they've needed that for the last 10 years. What about OSSTMM? the latest versions, according to ChatGPT, is version 3.02, published December 14th, 2010. It is anything but modern. It is anything but timeless, and it's actually bad. If you do pen testing according to these methodologies alone, you're gonna give a crappy pen test. I'm sorry to say. So what about OWASP then? Modern, up-to-date, volunteer work being done by people worldwide. It's a fantastic community, and they have quite a bit of guidelines, quite a bit of pen testing methodologies. For example, the WSTG, the Web Security Testing Guidelines. If you follow this methodology, you just have to test for this. Like just boom, like a a ton of checklists. Testing for SQL injection, if you have, say, Oracle, if you have MySQL, if you have, what about the other databases? Where's my time series? Where's my dirty dancing in Java Psychic signatures or dirty dancing in OAuth? Where's all of those things? If there's a new vulnerability out there, do I have to wait for them to update the methodology so that I can test for it? What about the people who create novel vulnerabilities? Who came up with, say, SQL injection? What about the people who use methodologies that allow you to find zero-day vulnerabilities? Clearly, something has to change, right? For hardware testing, OWASP also has a great framework for IoT or hardware testing. This little testing guide here will allow you to have a process on discovering things like, for example, command injection. But it's very much checklist driven. And it's not good enough because if all we do is testing for checklists, then who can come up with the novel vulnerabilities? Who can come up with, well, the things that are the known unknowns, so to speak. So a new methodology was built, long live the king because the king is dead, right? This methodology that we've built is meant to be more timeless. It is not meant to be all-encompassing everything like checklists, but if you do have frameworks like OWASP to follow, the methodology accounts for that too. But it all starts with discovery. What is in scope? And if you look at, for example, your badge for this conference, what does the badge contain? Does it contain an interface for USB connections? Does it contain an SD card? Can it read infrared signals? What can it do? Greatly depends on what you're gonna fuss and test for. It's going to greatly depend on what kind of hypotheses, what kind of ideas that you come up with on how to break the badge and take over it so you can control, for example, the diodes, the LEDs, etc. I'm going to use this methodology to talk a little bit more in depth about how to apply it and how to, use a team to support you in discovering what there is to attack, how to use a team, how to build out test cases, and how to essentially use this methodology to guide your testing, hopefully giving you ideas on what is in scope, and perhaps even more importantly, what you leave out of the scope. Because that is something that you yourself need to know about, and your customers also should know that, hey, we only tested for this, we did not test for everything else. Looking at hardware and IoT devices, there is some abstract ideas on what there is to attack. You have the hardware layer, the board, the components and the chips that might have weaknesses, that might have, ways to manipulate them. There's software on this device here. The software is where my expertise is. That's what I like to pen test. I'm not as good as hardware as some of my colleagues at work, for example, but I would be working on software vulnerabilities. And we've got some people in our organization, in our team, that are really good at understanding packets and network protocols. And I'm not going to do that because we've got somebody else who is good at that. Even attack surface could include cloud infrastructure or servers somewhere. In fact, in several of the hardware testing that we do at River Security, very often, perhaps more often than not, we find pivot capabilities into a cloud environment where we can go from a device like this into a cloud environment and from the cloud environment down to other devices. And if we don't cover the cloud, the connected infrastructure as part of our scope, some customers might believe that, yeah, our devices are safe. Well, they're actually not. But this is from a high level perspective. If we dig deeper, there is a lot of things to cover. What is in scope for testing a hardware device? Is the scope, like this image illustrates, is this scope to actually delayer all the chips on the motherboard, to solder them off, delayer them, and inspect with, well, microscopes what kind of buses are inside of every single chip? Because I don't have those capabilities. I don't have a friggin' ion cannon that can manipulate CPU microcode, which a company down in Abu Dhabi had. I was so impressed. Their hardware hacking labs looked like a hospital. They had an ion cannon, not like from Red Alert, but an actual tool to try to cause inference or interference or corruption, or try to make some weird behaviors, anomalies happen. Do you have the capabilities to do bus sniffing? Do you have the capabilities to interact with the different systems on chips, the different types of memory on the board? Do you have mobile application competency? Because, well, many hardware devices today have a mobile application companion. So now you have to be a mobile application pen tester too. And there might be a web server on the device. So you need to be a web application hacker to fully hack the entire thing. Clearly, that's out of scope for many, right? Even for us, we do several hardware tests during the year. We cannot test everything. So we have to plan out our course of action. Anyways, though, hardware hacking is pretty fun. If you ask me, it's like a full stack pen tester. This is the domain that encompasses pretty much all the other domains of cybersecurity. Within hardware hacking, you have to know a little bit about a lot of different things to properly figure out what vulnerabilities are on the system. And that's pretty cool. Take a look at this book here, for example, IoT Penetration Testing Cookbook. In this book, you will learn, and this is just copy paste from their book, okay? These are not my words. You will learn threat modeling. All right, that's cool. You're going to learn how to exploit firmware. All right, so firmware analysis, bin walking, running strings on binaries and understanding what operating system is on it to perhaps do some exploit development. That's pretty hardcore. That's learning curve is pretty high when it comes to exploit development. You're going to learn how to do iOS and Android attacks using MobFS. So you're going to learn a little bit about being a mobile application hacker too. You're going to learn a little bit about wireless protocols. Because, you know, there might be some Z-Wave, some Zigbee, some Wi-Fi type of interactions with whatever hardware you're testing. So you're going to be essentially a full stack pen tester if you're going to do hardware testing. And that's hard, which is why we utilize teams to do testing. Instead of just saying, let's hack this box, instead of doing that to one person, we should approach it more based on a team basis. So the methodology is supposed to allow you to, based on what you discover, prioritize different scopes to different pen testers, perhaps even at different times of the year as well, because the scope might vary. Like in this test, the scope might be just the hardware, but in the next iteration of the test, it could be the software. You're supposed to be able to categorize what you have discovered as potential scope and conclude what is in the scope with your team and your customer, so that you can, well, plan out your attacks accordingly. Based on what you discover, you're going to go into fussing. Based on what you are fussing and discovering of attacks, you're going to build out test cases and hypotheses, which are very much limited to what you're currently attacking. And business process and logic flaws is basically a container here for everything else that a scanner or software or hacking technique won't find. This is where you don't need AI, you don't need tools, you need to use your human brain to discover, well, basically how to break in. So, why do we do hardware testing? The motivation for many of you, I'm sure it lies down here for fun and profits. It's just a heck lot of fun, you know? It's like a journey of discovery, journey of learning. You want to break up something up and figure out how it works. But out there in the real world, there's actually a lot of market demand for not just hacking for fun and profits. There's a market demand in product security testing today. I talked with a company that does product security testing down in Oslo, and they're not a pen testing company, but they do product security testing, and they do pen testing on components. And what they do literally is that they have vendors send them devices, and they run a port scanner and a vulnerability scanner on the system, and they ship it back and report on it. That's all they do. But this field is actually growing quite a bit today. And I imagine more and more in the future, we're going to need to ask ourselves, is the product that we're going to market and sell safe for production? Is it something that we can deploy, yes or no? And it's going to be a requirement from the states, from the people who are going to put legislation out there. They're going to require you to do product security testing, and hopefully a bit more advanced than just running some scanners on the system. There's also a lot of demand for people who want to do their own repairs. It's your device, you bought it, you kind of deserve to understand how the device works. If, for example, all of a sudden, the device that you bought loses support because they shut down the cloud infrastructure, I would want to be able to patch my device so I can run it on my own infrastructure, so the device can keep on living, so the device can keep being supported just at my own garage or my own toolbox. And also quite a bit in competitive reverse engineering. There are, well, demands today where vendor A wants to understand how vendor B did something so they can start to compete on the same marketplace. Moving into the methodology again, if we look at fuzzing, for example, this is basically a step of the process where your job is to find, well, the 0 days, more or less. This is the part of the methodology where you're going to be fuzzing for some kind of anomaly, some kind of discrepancy. The part of the methodology fuzzing is basically for you to try to make the device do something unexpected so that you and your team can plan out a hypothesis, so that you and your team can try to figure out this discrepancy here could lead to maybe SQL injection, or it could lead to, say, firmware being dumped over a serial port, for example. This part of fuzzing is what might determine what you do next. And fuzzing, for some people, it means to send a bunch of mumbo jumbo to a port, for example. For some, it means that you're going to be doing, say, mutation-based fuzzing, where you're going to be trying to cause anomalies on the network protocol. But it depends on what you're attacking. Say, web application attacks. I will be fuzzing, for example, bytes. I'm going to be sending every script and every input. I'm going to be sending bytes of data to that application's script, and I'm going to see how it behaves if I send in a carriage return. If I send in a null byte, like %00, how does the application behave? Does it behave properly, or does it crash and burn? And also, I'm going to be fuzzing and looking for any kind of external server interaction. If I can make a device connect back to my device, that is typically a great clue that I'm onto some kind of vulnerability. Notice that I'm not looking for here, I'm not looking for, say, SQL injection in itself, but my methodology is going to guide myself into applying knowledge about SQL injection. My methodology is basically going to be my guide to learning what there might be, even a novel vulnerability or, say, a known vulnerability that we can apply. For hacking badges, etc., what I would be thinking, so we got our badge now. Some of us got it last night. I went out drinking beer instead of looking at it. But I know some of you did not go to sleep last night. You stayed up all night hacking the badge. But my go-to hypothesis here would be first to experiment with the badge, experiment with the board. What is its intended features? Actually, there are a few things that rub me the wrong way as much as hackers immediately trying to break something without first learning what the intended feature sets are. So play with the badge, see what you can do. For example, I would very often want to get the firmware The firmware will allow me to study its capabilities, study its type of feature sets and so on. But if I immediately start to try to break the badge by getting the firmware, I might miss the obvious solution, which is going to github.com and looking for the badge author's GitHub repository where all the firmware is already deployed. So the firmware is on the internet. So you didn't have to carve it out of the device. You can just go online and get it. The next thing I would probably do is that I would look at the board and I would study its different connectors, different places where I can connect my logic analyzers, basically software that allows me to read, transmit, and receive so that I can look for data ports. I want to look for somewhere there's a data connection, something that can be interpreted by a computer. And once I have that, I'm typically looking for UART, maybe JTAG interfaces, so that I can start to experiment with the tool, with utility, using, for example, a bus pirate here. I might be able to find a, say, admin interface that the developers have embedded into the device, and I can start to play with the admin interface. Maybe the admin interface has some nice console commands that basically allows me to root the device, maybe. Anyways, there might also be vulnerabilities across the different interfaces. On the badge, there might be, for example, a USB interface that can be interacted with, and I can open up my PuTTY serial to USB interface, and I can maybe talk to the software on the chip somehow. At DEF CON last year, for example, we got a really cool badge. The badge, we found there was even some information on the badge pre-conference, some leaked data about the badge. So using OSINT, we could discover, for example, that they were going to use the latest Raspberry chip, for example. But in my case, over at DEF CON, I did not have my bus pirates, I did not have my probes and connectors with me. So I was basically playing with the badge, figured out that I could interact with the badge by holding in a button. We could boot it up into admin mode or bootloading mode. From there, we could upload our own firmware. I had a 14-year-old kid sitting next to me who wrote his own firmware for the Raspberry Pi in less than 2 hours. I was mind blown. Me and his dad were drinking beer, and this kid's just flexing up his own firmware in a span of 2 hours. Super cool. In my case, though, what I did not manipulate the firmware. I basically interacted with the software itself that allowed me to upload my own binary files, and I created a little Game Boy game, essentially, that I could load up pretty standard via an SD card, and I just made the device say, this device is pwned by Chris. And I could also interact with different GPIOs. I can interact with different types of LEDs and so on. It was pretty fun. And I assume there's going to be similarities on this badge here at the conference. So hardware testing, anything but easy. If you're going to get into it, I recommend getting yourselves some tools, a bus pirate, get yourself probes that you can add or that you can use to connect to a board without having to hold the probes yourselves, so that you can connect it to a USB to serial interface, and you can start to play around with it in software. This is from the hardware hacking lab that we have in Stavanger. Vegard Linge Haaland is the true expert at hardware hacking in my company. I'm just the poster boy on the stage talking about it, really. But it is a lot of fun. This here is a router that was shipped to us from Ukraine, actually. And we tried to find zero-day vulnerabilities in it as part of one of our hacker spaces, where we get together and, of course, drink beer and do some hacking on some kind of side mission or side project. Hopefully, your biggest takeaway from this talk is methodology matters. And you cannot, or I mean, you should not have methodologies that try to cover every single tick, every single checkbox item, because your methodology needs to guide you into finding the true zero-day vulnerabilities out there. As a team, try to work together. What is there to attack? And as an example, I'm going to bring up a website. For example, something super simple as attacking this website here. Front websites running WordPress, okay? You discover it's running WordPress. All right, are you going to fuss the entire code base of WordPress? Is that your job, acting as a pen tester towards, say, this application? Probably not. So you're going to have to apply methodology on finding vulnerabilities in WordPress. There are specific tools for finding vulnerabilities in WordPress. WP Scan, for example. So based on what you discover, you're going to apply a very specific methodology. We call this minimum viable pen testing. But when I go up here and I find that I have WordPress, my cursor is somewhere, there it is. You will see that there's also more attack surface. I have Google Analytics. So what can we do with Google Analytics? Can we hack Google Analytics? Well, we don't want to hack necessarily Google Analytics, but using the tag, the GTM tag of Google Analytics, I might pivot into other systems running the same Google Analytics code. And knowing that it's HubSpot, there's a file system behind HubSpot that might have files and content on it that could be interesting to discover weaknesses on. The methodology is what's going to guide us into what we attack and what we don't attack, so that the customers can get a proper understanding of their risk. And if you apply continuity to this, continuous pen testing, then it gets really, really fun. All right, so I had to complete my talk in 25 minutes, but that's pretty much it. So thank you. I'm going to be around looking for the golden duck. Oh, sorry. I'm going to be around taking questions. So if you see me up at the booth or if you see me anywhere, really friendly, come talk to me. Yeah, we'll have the next speaker come up.
Thanks, Chris.